Let's talk about conic sections, which a lot of people call conics. By definition, a conic section or conic is a shape resulting from intersecting a right circular cone with a plane. So I got two right circular cones here that are touching each other, and the blue part is that plane. So you can think of it like a flat board essentially slicing through that double napped cone. And the idea is there's a couple different types of shapes that could happen when they intersect like that. First one here, it's going to look roughly like, ooh, that didn't go well. Let me try again. Roughly like, that's better. Like that shape. And if I pull it over here into 2 dimensions, it's kind of a oval type looking thing, which in math we call an ellipse. So in 2D on a Cartesian coordinate system, it looks a little bit like that. If you were to write out the form of these, they always look like x minus h squared over a squared plus a y minus k squared over b squared is equal to 1. So you'll always have the x and y are the variables, the h and the k are specific numbers, and so are the a and the b. So for example, something like x squared over 16 plus y minus 7 squared over, say, 9 is equal to 1 would be an example. So my h is 0 because I don't see any subtraction here. My k is 7, my a is 4, and my b is 3 is equal to 1. So anything that looks like this is going to be an example of an ellipse. Next option is if that plane hits it at a really nice angle. If that's what happens. Oh, that backside did not go very well. That happens in 2 dimensions, that's going to be a circle. So we put it on a Cartesian coordinate system, it looks something like the following. Well, we've worked with circles before, and they look like x minus h squared plus a y minus k squared. We worked with is equal to r squared before, but if you divide everything by r squared, we get an x minus h squared over r squared plus a y minus k squared over r squared is equal to 1. So something like x minus 2 squared plus a y plus 1 squared is equal to 1, and we'll divide by, say, 4 and 4 on this one. So my radius, if you move that over, would be a 2 because 2 squared is 4, but the center of that is 2 comma negative 1, which you're used to working with. But most often in these chapters, we'll see that r squared is in the division. Third option, which technically it's really the second option because the circle is an ellipse, it's just the a and the b are equal to each other. So third or second option, depending on which way you want to think about it, is if we cut it in this direction, and you'll see that there's 2 parts to it. There's a part up here, and then there's also the part that we get down there. I forgot to write that. This was an ellipse. This was a circle. And on to this one. This one is called a hyperbola. And if you draw it in 2 dimensions, you got 2 parts to it, something like this and something like that. Or for example, let's see, if you put it in 2 dimensions, there's a couple options. They could be opening up to the side, like this. Ooh, not the best drawing I've ever done. Or they could be opening vertically, like this. Okay, so there's 2 options. So first option over here, you're going to have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So you'll see the difference on the hyperbola is I have a minus in the middle instead of on the circle and the ellipse. They both had a plus. And it could be that the x came first on this one, but you could also have y came first. So in other words, the other option is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So depending on which one is the positive, which one's the negative, we'll give you one of these 2 pictures. So this one is that guy, and this one is that one. So for example, you could have x plus 3 squared over 8 minus y plus 4 squared over, oopsies, sorry about that, over 10 is equal to 1. So on that one, your h would be negative 3, your k would be negative 4, a would be the square root of 8, and b would be the square root of 10. So that would be one example of a hyperbola. Last one we want to talk about is what if it only hits one of these at an angle? Well, then you're going to get something that looks like the following. Yeah, which that's called a parabola. We've seen those before. In 2 dimensions. They often look a little something like this. You could also have one that opens up to the side instead. So you do have 2 options. If you have one that's opening up, it's going to look like x minus h quantity squared is equal to 4 times p times y minus k. Now, you'll notice that that's a little different than the form you're probably used to working with. Usually we're just, the one I have drawn there is y is equal to x squared. And that's perfectly fine. You can fit it into that form. My h would be 0 because there's no subtraction. And let's see, well, I got a y here. There's no minus k, so k is 0. And then 4 times p, well, I don't have anything here, so that's 1, so my p would be a 4th. So it does fit that form. It's just looking a little different. The main part is you'll notice on these parabolas that one of the variables has a square on it, the other one does not. That's different than the other previous 3 that we talked about. The sideways looking one is a y minus k squared is equal to 4 times p times x minus h. So again, you'll see that one of the variables, y in this case, is squared. The other one is not. So those are the types of conic sections. And in this class, all we want to do is be able to categorize which one of those am I looking at. If you're heading on in math, there'll be more time in one of the classes to come where we work more on essentially, well, where are those sitting? Because these can move around, the hyperbolas can move around. You don't have to, you guys saw with circles, you don't have to have your circle right at the origin, same with an ellipse. You can move them somewhere else too. So, all right, so for now, let's just talk about categorizing them. Well, this looks like, well, both of the variables are squared, so it's not a parabola. It has a plus in the middle, so it's not a hyperbola. So that brings me down to circle or ellipse. Well, the circle had the same number underneath both of the variables. I have a 6 for both of them there, so this guy is a circle. Moving on to the second one, let's see, I have a plus in the middle, and both variables are squared. Well, that's either an ellipse or a circle. But you can see I have different numbers underneath the variables, so that's going to be an ellipse. Oh, this one's got a minus in the middle. Both variables are still squared, so this one's a hyperbola. On this one, notice how the y is squared, but the x is not. So only one of my variables is squared. That tells me I got a parabola. Number 5. I'll let you think for a second. There's a minus in the middle. Both variables are squared. That's a hyperbola. Number 6. One of the variables is squared, x in this case. One of them is not. It's just y. That's a parabola. And last one, both are squared. And there's a plus in the middle, so that tells me I'm either looking at a circle or an ellipse. And x squared is over 4, but y squared is over 1. Those are different numbers, so that is an ellipse. And I didn't mention it on most of these, but all those ones that I was talking about, whether I had a plus and both variables were squared or I had a minus, they all had 1 on the right-hand side. So number 7 had 1 on the right-hand side. Number 5 had 1 on the right-hand side. Number 3, number 2, and number 1. So I didn't mention that because all of the circles, ellipse, and hyperbola are essentially in that form. But down the road, just be careful. You could have ones that didn't have a 1 there to start with, and you'd have to do something to figure it out a little more. So that's an introduction into what conics are.